Okay, so hopefully you're back here for more AP Calculus, and we're going to be looking at the practice test here, or the practice final. And we're start at number 3, and we're going to see how many we can get done. Yeah, let's just get started. Question 3 says the integral from e to 4e of 1 over x dx. Let's remember that the antiderivative of 1 over x is the natural log of x. So using antiderivatives, this would mean that the integral from e to 4e of 1 over x dx would be the natural log of 4e minus the natural log of e. Now, to successfully complete this problem, we do need to know that the natural log of e is equal to 1. So we can make that substitution pretty quickly. So this is going to be equal to the natural log of 4e minus 1. The next identity that we should use here is that the natural log of a times b is the natural log of a plus the natural log of b. Applying that rule to the natural log of 4e, we get ourselves that the integral from e to 4 over e to 4e is a natural log of 4 plus the natural log of e minus 1. Well, again, the natural log of e is 1, so we get ourselves the natural log of 4 plus 1 minus 1, and that's just equal to the natural log of 4. Question 4 asks for an average value of f of x on the interval from 0 to 2. Let's get the average value formula. So we get the average is equal to 1 over b minus a multiplied by the integral from a to b of f of x dx. Let's substitute our values in here. We know that we're going from 0 to 2. We know that f of x is 3x squared minus 2. So we have ourselves a formula for the average value. Now we just have to integrate. So this is equal to half of x cubed minus 2x from 0 to 2. That's going to be half of 2 cubed minus 2 times 2 minus half of 0 cubed minus 2 times 0. And that just works out to 2. Question 5. What is wrong with this one? The integral of f of x plus g of x plus 4 times h of x minus g of x. That's equal to, well, clearly you can separate this at the plus sign and the minus sign. So let's separate that. We got the integral of f of x gx of dx. I don't see anything wrong with that. And the next thing we have is 4 times the integral of h of x minus g of x. And I do see a problem there. That 4 was taken out of the integral. So the integral, either the integral is in the wrong place or we factored the 4 incorrectly. So let's see how this should have been done. If we are going to put this into two integrals, then the first integral is going to be that f of x multiplied by g of x, and this second integral is going to be 4h of x minus g of x. Notice how the 4 over here is on the outside of the integral, and over here it's on the inside of the integral. So that's one way that you might see it. One popular way of also simplifying this further, well, popular among calculus teachers anyways, would be to factor out that 4. Now, if you're going to factor out the 4, you're going to need to put a 1/4 here to balance out that factor. So we're missing that 1/4 right over here in front of the g of x. So a couple things that could have gone wrong here. The second integral is factored into correctly. Okay, number 6. We've got the integral from 0 to 6 of f of x dx is 6, and the integral from 0 to 2 of f of x dx is equal to -3. And we're supposed to find the integral from 6 to 2. So I'm looking at this question, and I see some numbers here. First of all, I see the 0. I see a 6. And I see a 2. So if I was going to straighten this out, I don't know if that's the correct way of thinking about it, but if I want to break up at the integral of f of x from 0 to 6 into two regions based on what I'm seeing here, I would say that the integral from 0 to 6 of f of x is equal to the integral from 0 to 2 of f of x plus the integral from 6 to 2. And now notice how those endpoints match up. So the 2 and the 2, and then the 6's over here and over here. So everything is in order now, and I'm going to substitute for those values. The integral from 0 to 6 over here, that is equal to 6. The integral from 0 to 2 over here, that's equal to -3. And using a little bit of algebra, we get ourselves that the integral from 2 to 6 of f of x is equal to 9. Now, take a look at what they're asking. They're not asking for the integral from 2 to 6. They're asking for the integral from 6 to 2. So in order to get that, we need to change the limits and make them upside down. So the integral from 6 to 2 of f of x, that has to be equal to -9. So that was a fun problem. Let's take a look at number 7 now. Number 7 says, use the fundamental theorem of calculus to evaluate the integral from 1 to 3 of 1 over x cubed dx. So what fundamental theorem of calculus are they talking about? Well, they're talking about this fundamental theorem of calculus, which is, the basic one, the integral of a derivative. Now, in order for us to get through this, we're going to have to figure out an antiderivative. So the antiderivative of 1 over x cubed, so we are asking ourselves the derivative of something is 1 over x cubed. And if we do this with our rules, we get that the antiderivative is -1/2 of 1 over x squared. So that's going to help us. We can first substitute the derivative part into this, and then we'll substitute the antiderivative. And now that we've substituted our antiderivative and our derivative, we're going to substitute our lower limit and our upper limit. A is 1, B is 3, and then now we're going to have to do some algebra. And that simplifies to 4 over 9. All right, so that was pretty quick and easy, I think. I think maybe the thing that we might help you if this one is giving you problems, maybe if we remember the power rule as it applies to integrals, that might help us out a lot. So there is our problem for number 7. Let's take a look at question 8. We're supposed to solve the initial value problem using the fundamental theorem, and your answer will contain a definite integral. Okay, let's go ahead and get our fundamental theorem going. There we go. It's the same fundamental theorem. Our function is capital letter G instead of F. And we know that G of 0 is 4, so we're going to change all of our A's to 0. And if I want my function to be a G of X, then I'm going to have to change all the B's into an X. So let's go ahead and do that now. Change that to an X. Change this upper limit into an X. And if I do that, I'm going to have to change this from an X inside the integrand into a T, because we can't have the variable of integration be the same as the variable in the upper limit. So that is what we're looking at. Let's substitute here. Okay, the first substitution here is g of 0 is 4. Let's change the g of 0 into a 4. And the next substitution is g prime is this cube root of tangent x. So let's just change g prime to the cube root of tangent x. And instead of x, though, we're going to change that to a t. Solving an initial value problem means we're getting a function for g of x. So I'm going to have to solve for g of x now. Not too difficult. And that should do it. G of x is the integral from 0 to x of the cube root of tangent of t dt plus 4. Okay. Notice that this says your answer will contain a definite integral. And also, this is calling itself an initial value problem. So solving an initial value problem means we have a function for g of x. So there we go, number 8. And let's take a look at question 9. We've got, given that f of x is equal to the integral from 1 to x squared of t cubed plus root t dt, we're supposed to find f prime of x. Okay, well, let's figure out this then. So we're going to do this a couple of different ways. Maybe the first way we should do this is to do this the long way. So this is the long way without using the second part of the fundamental theorem. Well, we know that f of x is equal to this integral. This integral is actually, we can actually get an antiderivative for this one, which is not always the case. But if you can get an antiderivative like this, we could just get an antiderivative. See, that wasn't too painful at all. The next thing we're going to do is substitute our limits and take a difference. Okay, so substituting an x squared into the in for t, and then substituting a 1 for this value of t in the second part, and then finding the difference. That gives me, after simplification, that f of x, well, that gives me 1/4 x to the 8th power plus 2/3 x cubed minus 11 over 12. Now the next thing to do is find f prime of x. So let's go ahead and do that now. If we take f prime of x, well, we'll take the derivative of each one of these terms. So that gets us that f prime is 2x to the 7th plus 2x squared. Now that didn't seem like too much mental energy, but remember that sometimes these are constructed so that you can't actually find an antiderivative. The correct way to do this, I don't recommend doing this first way. So using the fundamental theorem, we recognize that we're taking the derivative of an integral. And when we take a derivative of an integral, we look for a variable expression in the top limit, and we substitute that variable expression in for t. And then we multiply by the derivative of that upper limit. Now, if we have a lower limit that's not a constant, we could also do the same thing. I'm going to move this back into derivative notation just so that we can make our point here. But we're going to subtract now. We're going to subtract substituting 1 and then multiplying by the derivative of the lower limit, which is 1. Again, if we know that the lower limit is constant, we don't actually have to do this because we know right away that this derivative is going to be 0. So we're kind of wasting our time by putting this entire second expression over here. All of this right here is a waste of time, but I just kind of wanted to show you why that's a waste of time. So now that we know that this is going to be 0 on this second part of the equation, we can concentrate on the first part of the equation. We get ourselves that the x squared to the 3rd power is x to the 6th. The square root of x squared is just x. And then the derivative of x squared, that is just 2x over here. And when we simplify this, we get 2x to the 7th power plus x squared. Now this right here, this is the way that you are meant to do this problem. You are not meant to find an antiderivative and take a derivative because, you know, like I said before, you're not always going to have a function in there that you can find an antiderivative with. So that said, let's move on to number 10. And in question 10, it says we're supposed to use a trapezoidal rule with n equals 3 to evaluate the integral from 2 to 8 of 2x cubed dx. Now, if we're going to use n equals 3, that means we're going to need to divide this between 2 and 8. We need to divide this into 3 different regions, or 3 different subintervals. So one way that you can do this is to figure out your delta x, and your delta x equation is going to look like this. It's b minus a over n, and if we have 8 minus 2 over 3, that means my delta x has got to be equal to 2. So we'll just go ahead and put 2 for all of our delta x's, since we know that that's got to be our, our delta x. We just solved for it. Okay, now that I have that, we can go ahead and put our intervals. The first one is going to be 2 to 4. The second one is going to be 4 to 6. And the last one is going to be 6 to 8. I notice that 2 and 8 match perfectly with my integral. 2 as the lower limit, 8 as the upper limit. So it looks like I did this correctly. The next thing we're going to need here is the height of the rectangle. And so the height of the rectangle has got to be half of the 2 heights on the left and the right. Okay, the second interval from 4 to 6, we know that the height is going to be the average of f of 4 and f of 6. And for the third one, the height is going to be the average of f of 6 and f of 8, which means we're going to have to calculate a few things. Let's get f of 2 first. 2 cubed is 8, and 8 times 2 is 16. You don't really get a calculator here, so you're going to have to use your, well, you have to use your superior knowledge of algebra. Okay, so let's get all of these. F of 4, we're going to have to do 4 cubed. That's 4 times 4 is 16, times another 4, that's 64. 64 times 2 is 128. So that gives me that first one. Since I know that f of 4 is 128 already, that kind of helps me out here on the second one. We got a half of 128 plus, okay, let's find out 6 cubed. That's 216. And again, that helps me with the very next integral because I have that f of 6 yet again. I'm noticing that I made a little bit of an error. 6 cubed is 216, but then I have to multiply by 2 again. So that gets me 432. Let's add and get averages. Okay, with all of those done, looks like the height here for the first interval is 72, second interval is 280, third interval is 728. And let's just assemble together our trapezoidal approximation. My first trapezoid is a width of 2 and a height of 72. My second trapezoid is a width of 2 and a height of 280. And my last trapezoid has a width of 2 and a height of 728. Now I gotta tell you, when I'm saying height, I don't really mean height. I really should be putting height in quotes there. I have been putting them in air quotes, but of course, you know, this is online and you can't see me putting the air quotes in there. But yeah, this is not really the height. It's the average of the height on the left and the average of the height on the left and the right. So let's put this all together and add these. And you should get yourself a 2,160. So this is a good place to stop. This was questions numbers 3 through 10, and we'll see you online for the next one of these AP Calculus practice finals. Have a good one.